In this video, I will briefly review some loss functions, important loss functions for regression. So in the regression problem, we want to minimize the distance between our predicted output and the real output y. So let's say fxi is the output of our machine learning algorithm, and yi is the ground truth output y. And we want to define some loss function that can measure the distance between fxi and yi. One very famous or popular measure or metric for this purpose is mean absolute error, or sometimes called L1 error because it comes from L1 norm. This basically just compute the absolute value of fxi minus yi. It's very intuitive. The second popular or famous algorithm metric is mean squared error, MSE, and this is what's called L2. And this is simply the square of fxi minus yi square. Okay. Then let's compare L1 loss and L2 loss. Which one is better? When we have to use L1 loss, when we have to use L2 loss. So to understand the difference between L1 loss and L2 loss, let's draw graph of L1 loss and L2 loss function. So let's say this is x minus y. This is y-axis represent loss value. Then L1 loss is this. This is L1 loss function shape. And when you draw the same graph, L2 loss looks like this. Okay. So when it comes to gradient, for L1 and L2 loss function, for small loss function and for large loss function value point, with L1 loss function, we will observe constant gradient value for every range of x minus y value. But with L2 loss function, you will see very tiny small gradient value for small loss function point, and it increases monotonically. And for a large loss function value point like here, you will see very huge or large gradient value. That is the main difference between L1 and L2 loss function. And another point is, at this point, the L1 loss function is very sharp. This is not smooth at all. So people say L1 is non-smooth function. The gradient of L1 loss function jumps at 0 point. On the other hand, L2 loss function is very smooth. The slope is very smoothly varies over all range. So L2 loss function is smooth loss function. That is the difference between L1 and L2. When a function is non-smooth, this is very bad property for optimization per se. For instance, if you want to optimize a function using gradient descent algorithm and the gradient is not smooth at all, then it is very easy to observe the oscillations and you never converge to the optimal point. Even if you iterate an infinite number of times, you cannot converge to the optimal point. But when you have a smooth function, your optimization process becomes very easy and you can very easily reach to the optimal point. So in terms of optimization, L2 loss function is better than L1 loss function. But why still some people use L1 loss function, although the optimization property of L1 loss function is worse than optimization property of L2 loss function? L2 loss function, one very crucial drawback of L2 loss function is it is very sensitive to outlier. Okay, if there is some point who far from normal data point which will incur very huge xi minus very huge yi minus fxi value. When this value is huge, the square of this value will be extremely large. Okay, so this value will dominate all other loss values or other training data point, and your training process, your machine learning process, will be dominated by few outliers, and the final outcome of your algorithm will be poor because of few outliers. On the other hand, with L1 loss function, because we don't have square term, the dominance of the outliers are just a minor thing. This is controllable. Okay. All right. So L1 has some good thing, and L2 loss function also has some good thing. So let's combine them. This is called smooth L1 loss function. So define loss function fxi and yi in this way. 0.5 times fxi minus yi square if fxi minus yi absolute value less than or equal to 1. Otherwise, absolute value of fxi minus yi minus 0.5. Then this loss function is smooth, and also we don't have square term for huge difference point for the outliers. So we can escape from the outlier issue and we can escape from the smoothness issue. So we bring all the goodness of L1 loss function and L2 loss function, right? So nowadays people love to use smooth L1 loss function.